No problem. Assalamu alaikum students. Let's start with our lecture number 18 today. We were studying the point-to-point application architecture. In that we have looked into direct file transfer between point-to-point links, and we have looked into the scenario of BitTorrent. Okay, and the third topic in this context was Skype case study. Okay, Skype is also a point-to-point application. Okay, let's have a case study of Skype and look into it, how it works basically. It is basically these are your Skype clients here. Okay, SC Skype clients. Okay, they communicate inherently in point-to-point, in pairs of users communicate with each other. Okay, definitely this Skype client does need another Skype client to start its communication with it. Okay, proprietary application layer protocol they have, and they inferred via reverse engineering their proprietary protocol, and hierarchical overlays with super nodes. Okay, now the question is this, that how they can communicate with the supernode. Supernode is one of the node with which the Skype client communicate first. Okay, and they have the index maps. In the index maps they have the usernames. For example, I have one username on a Skype. Okay, when I use that username on the Skype application, definitely that username has to be binded with an IP address, and that IP address will be the IP address of my computer on which I am using that username on a Skype application. Okay, so the index maps usernames to the IP addresses, and these are distributed over the supernodes. So this supernode will take care of this index mapping. Okay, every client, Skype client, which is using a username on the Skype application, definitely his computer will be having an IP address. So username to IP address mapping, okay, will be recorded here on the supernode. Clear? Now, like this, some of the computers will be communicating with their own supernode, and some of the Skype clients communicating with its supernode. Why the supernodes are there, and the supernodes will be connected with each other. Okay, what is the use of these supernodes? You know that if you are inside a LAN, okay, and the other party, Skype party, okay, that party is also inside their LAN, his LAN. Okay, now on the gateway router we are doing a NAT. So NAT router is acting as a firewall also. So outside of the NAT router, okay, nobody can initiate a connection from outside of the LAN to the inside of the LAN. So how a party which is not in your, a Skype client which is not in your LAN, he can initiate a connection into your LAN with you, and if you are not in his LAN, how you can go and communicate with that Skype client into his LAN? You are not allowed to communicate into another LAN, and he is not allowed to communicate or to set up a connection into your LAN. So this is not allowed. You are behind the firewall, behind the gateway router, NAT router. So nobody else can reach you unless until he is allowed to do that thing. Okay, so now this is the issue here in the Skype. So Skype will have a basically login server where your login name and passwords will be kept. Okay, so every supernode will get the help of the Skype login server in order to authenticate your username and password. Once your username and passwords are authenticated by the Skype login server, you will be not communicating with the Skype server, rather you will be communicating with your supernodes. Okay, now the problem will come when both Alice and Bob both wants to communicate with each other, but the problem is this: Alice and Bob are behind the NAT, network address translation router. Okay, NAT. Why? Because the NAT, it prevents an outside peer from initiating a call to an insider peer, because he is the outsider. He is the outsider. He is not the insider into your LAN. So he cannot initiate a connection into your LAN, and you cannot initiate a connection into his LAN because you are the outsider for his LAN. Clear? Now this is the problem here, that if you are behind the NAT and he is behind the NAT, you either cannot initiate a connection into one another LAN, each other LANs. This is the problem. Why? Because you are behind the NAT router. Now what is the solution? How Skype handled this problem of NAT router? How they can bypass the NAT router and they can initiate the connection inside the, because when you are talking to another Skype client, you are talking from your LAN and he is sitting in his LAN. So how you can initiate a connection while sitting into your LAN into his LAN? And why he can initiate a connection while sitting into his LAN, from his LAN into your LAN? And you are sitting into your LAN, from your LAN you want to initiate a connection into his LAN. Both are behind the firewalls, behind the NAT router. So the Skype provided the solution to handle this issue using Alice and Bob supernodes. So Alice supernode and Bob supernode. What they do, they act as a relay. Okay, using Alice and Bob supernodes, relay is chosen. For example, this will be chosen, the supernode for the Alice and the supernode for the Bob. What they will do, they will choose another supernode, okay, another relay, okay, and they will ask Alice and Bob to chat through that relay, to initiate a connection through that relay. Okay, so that relay will act as a relay for both Alice and Bob. Each peer initiates a session with the relay, and relay will relay the message into their clients, into their LANs, to the clients. Peers can now communicate through the NAT via relay. They can communicate even through the NAT, but by getting the services of the relay client. So relay client are just relaying their message to the client inside the LANs. Okay, this is the solution provided by the Skype. And socket programming is a way of designing the application. Okay, client server application. Okay, in order to design the next topic is socket programming, and you have both the topics here, socket programming with UDP and with TCP, because one protocol is on the transport layer, unreliable, connectionless, other is connection oriented and it provides you the reliable services. Now let's have a first look on the UDP protocol socket programming with the UDP protocol. What is socket programming? Why we use socket programming? Basically, when a client wants to communicate with a server machine, definitely client will have an IP address and server will have an IP address. Client machine and server machine both will have the IP address. But as you know that on the client machine there could be more than one processes running on the client machine, as well as more than one processes are running on the server machine. Now when some request will come to the server machine from any of the client, how the server will decide that this request should go to which process? Because there are more than one applications are running, and for each application there will be a process listening the client requests on a particular port. Unless until you specify the client specifically by identifying some logical number, which is called here the port number, the server machine cannot differentiate between the client request coming to the arriving on the server machine. So every process must be allocated a port number, unique port number. Okay, port number is a sort of a address for the process on which the process is listening. As we have an address on the data link layer, which is called the hardware address or the MAC address or the physical address. Same like that, we have address on the network layer, which is called the IP address, logical address, software address. Clear? Same like that, we do need address on the transport layer, which is called the port address. Clear? Why we have a physical address on the data link layer? To differentiate the computers which are on the same LAN, same Ethernet. Okay, why we have an IP address on the network layer? To differentiate the host computers, host machines over the internet. Why do we need the port numbers on the transport layer? In order to differentiate the processes running on a particular host machine. If I open here 4 applications, internet applications for example, all the 4 applications will be running on the same computer, same IP address, same physical address, same MAC address, same one MAC address, one IP address. And how many applications are running?
4.
For every application at the back end, there will be a process which will be running. So 4 processes are running. If multiple clients are going to send requests to this machine, how this computer will differentiate that these requests should go to process number 1, process number 2, or process number 3, or process number 4? To which process these requests should go? Maybe 2 requests should go to process 1, 2 requests should go to process 2, 3 requests should go to process 4, 4 requests should go to process 4. So there should be some mechanism in order to differentiate these 4 different processes. So that way of differentiating these processes is called by allocating them the port numbers, unique port numbers. And we discussed here in our previous lectures that port numbers from 0 to 1024 are reserved for the well-defined services. And if we want to make our own application to give particular service, we can use the port number greater than 1024, starting from 1025 to 65,536. Clear? So here in the socket programming, we will be using a combination of both IP address and port number. Okay, as we discussed already that in our previous lectures, that every host computer, for example, this is a host client machine, okay, and this is a server machine. This is a server. Okay, server will have definitely an IP address. For example, this is the IP address of the server, and this is the IP address of a client. Okay, this is another client. It is also having an IP address. Here on this machine you are running a DNS service and HTTP web server also. HTTP listens on port number 80, very good, and DNS listens on port number 53. Clear? Now for these 2 services, this server should have separate processes. For the DNS service, a separate process running on this server for the HTTP process. You have 2 applications, 2 services running on this one machine, one server. You can run more than 1 services on one machine, one server. Okay, if it is a server machine, okay. But the best practice is that you should run different services on different servers, so that when a huge number of hits or the requests will come to the server, it should not be slowed down. Okay. Now 2 services are running on the same machine, same IP address. So one process, both the processes, process for DNS, process for web server, both the processes are running on the same host, same computer. When the request from this client will come to this server, if it is a DNS request, and a request is coming from this computer which is HTTP request. How this server will differentiate that this request should go to which process? Because both the processes are running on the same computer. That is why the server host will assign a port number with the IP address. Concatenate or link a port number, concatenate a port number with the IP address. Now this is one socket, this is another socket. The DNS service, the DNS application process will be listening on this socket. The process of the DNS server will keep on listening on this socket, and the process of the HTTP server will keep on listening on this socket. What is a socket? Socket is a combination of IP address concatenated with the port number. This is a socket. IP address concatenated with port number is called a socket. Clear? Here this IP address is concatenated with its port number, DNS port process port number, and on the same host you are running another process for the web server whose port number is 80. So how many sockets are there? 2 sockets. Here on the client computer, its operating system will assign it a port number, and its port number should be greater than 1024. For example, it got a port number 1026 and its client operating system can assign it a port number. Now both the operating systems are running on 2 different computers. You might ask a question that can both the operating system assign the same port number? Yeah, they can randomly assign the same port numbers, but their IP addresses are different. Clear? So it can assign it a same or different port number greater than 1024. Both are greater than 1024. So this is the client socket, and this is another client socket. This is server socket for the DNS process. This is another server socket for the web process, HTTP server. For the DNS server, for the HTTP server. So 2 sockets. Now the communication will take place between a pair of sockets. Now one pair of socket will be this one, and the other pair of socket will be this one. This is pair of socket for HTTP communication. This is a pair of sockets for DNS server communication. DNS client server communication. Always you should have a socket on the client side and a socket on the server side. When the pair of sockets will complete, then the communication will start. And to complete one socket on the server, you need server IP with server process port number. Here on the client side, you need a client IP with the client port number. This is one socket, client side socket. This is server side socket. Once this pair is complete, the communication can take place. When this pair is complete, the communication can take place. 24, yeah, exactly. And here these are the well-defined services. So these are less than 1024. In between 0 and 1000. For well-defined services, these should be 1024. And if you want to use, you want to create your own applications, you can use port number greater than 1024 till 65,536, something like this. Clear? Is the concept of socket is clear to you? Socket, what is IP concatenated with the port number? What is socket? and what is a pair of socket and how the communication will take place between a pair of socket. Why we use port numbers? We use port numbers to differentiate the services running on the same host. For example, you can run more than 2 services even on this computer. It's mean more than 2 services mean there are more than 2 processes are running on this machine. How the processes, if the request from multiple clients will come to this server, how this server will make a differentiation between the requests, that which request. Now you exactly know that the client process will establish a connection with this server socket. It's mean the request coming from this clients will be directed to this socket, to this particular process on this particular host on the network layer. Once it reaches, the request reaches on this particular host on this computer on the internet, this computer knows that on top of the network layer it should go to which process, because on the network transport layer 2 processes are running, one for DNS server, one for HTTP server. So the DNS server request will be directed to the DNS server process, and the HTTP request will be directed to the HTTP process. Clear? Both the process are listening on different port numbers for the client requests. Yes?
The server can't run 2 applications, DNS request?
This server is particularly running 2 services, DNS as well as the HTTP.
2 applications is DNS.
No. Because it will have the same socket in that case. It is not allowed. Yeah, it can't. On the same host. If you change the IP address, then it is possible.
Yes,
yeah, definitely. Okay, clear? So, socket programming, it is the goal of socket programming is to learn how to build client server application that can communicate using the sockets. Okay, so this I have explained you here on the board. Now the socket API, application programming interface, basically the programming languages, they have the socket APIs in it. It is introduced in the BSD 4.1 Unix in 1981 and explicitly created, used and released by the application programs. The application programs, they basically create the socket, they use the socket, and at the end they release the socket. Okay, it is used in client server paradigm. Okay, as we have seen that clients are requesting the DNS service, or one client is requesting the web service. Okay, 2 types of transport services via the socket APIs can be provided: UDP services or the TCP services. UDP services are connectionless services, unreliable services, whereas TCP services are connection oriented services and reliable services. Okay, what is a socket? Socket is basically an application created, OS controlled. Who will create the socket? Application program will create the socket, but who will control it? The operating system. Okay, interface, it is like a OS controlled interface. It is like a door, okay, in this computer, okay, into which application processes can both send and receive the messages to from another application process. Because application process is running on this client will communicate with an application process running on this server machine. Now here on this client machine there will be an application process running for the web browser. Okay, it will communicate with the web server process on that server. Here a DNS process, client process will be running, which will communicate with the DNS server in order to get resolved the URL into IP address. So the DNS client process will communicate with the DNS server process. Whatever request you will type in the web browser, the URL, it has to go to the DNS server in order to be resolved into an IP address. Then the request can be sent on that IP address. This we have studied already. Okay. Socket programming basics are, is it clear or not? Not clear? Okay. For example, on this client, you are going to write www.google.com. Okay. As I told you already that router, the devices over the internet, they can't understand the English-like language. They do need to understand this language. They do need to convert. They have to convert it into the IP addresses, 32-bit binary number. Okay. So who will convert this URL into an IP address? We do need a conversion of this URL into an IP address, which is a number. For this resolution, you do need a DNS server here. So whenever you type a request in your browser, the request first goes to the local DNS server on the LAN. The DNS server will look into its database for the corresponding IP address for this URL, Universal Resource Locator. If it finds the IP address in its database, it will return the IP address. That on that IP address the request will be forwarded or sent. When we studied the DNS topic, that time we looked into this conversion. We have looked into the root DNS server, top level domain servers, and the authoritative domain servers, and the local domain servers in the company. Clear? Is it clear now? Server must be running before the client can send anything to it. Any request, to welcome the request of the client, the server should be running well before the client. Okay. So server should be 24/7, it should be on, kept on. Anytime any client can send a request to the server. Once the request is sent to the server process will be keep on in the listening mode, and it will be welcoming the client request. It will receive the client request. Clear? Server must have a socket door. This is the socket of the door of the server, through which it will receive the client request and it will send the segments back to the client. Clear? Similarly, on the client side, on the client host, we do need a client socket, a door on the client's computer, which will receive the request from the server and send the request to the reply from the server. It will receive on that door the replies coming from the server, and it will send request to the server from that door. Clear? So these are the doors. 2 doors on the server, and each door, 1 door on each host. Clear? Socket is locally identified with a port number. The operating system of the computer, client computer, will assign a port number. This is fixed IP, you have assigned it. Either it is statically assigned or it is assigned by the DHCP server automatically. But for this computer, this is the fixed IP address right now. But it has to be assigned a port number. Okay. So it is analogous to the apartment number in a building. You could say in one building you have 2 apartments. If you keep on increasing the services here, in the same building you can have more apartments. Clear? In one building you can have more apartments. It is analogous to a building containing multiple apartments. One building having multiple apartments means running multiple services. Clear? Client needs to know server IP address. Now this client machine, it does need to know the server IP address. What is the server IP address? Along with its port number. It means the client has to know the socket of the server, because the client socket will send a request to the server socket. If it is a TCP socket, it will send a request to establish a connection first. If it is a UDP socket, it will not send a request to establish a connection first, because UDP is a connection less service, whereas TCP is a connection oriented service. So TCP directly start sending the byte streams to the server. TCP UDP socket will directly start sending the byte streams to the UDP server socket, client socket to the server socket. Clear? So, but the client needs to know the server IP address along with its port number, mean it should know the server socket. Okay. UDP is a connectionless protocol. That is why UDP is not asking for a connection between the client and the server. So no handshaking is required. So there is no need of establishing a connection between the UDP client and the server. Sender explicitly attaches IP address and the port number of the destination to each segment. Each segment the client is going to send, it will attach the IP address and the port number of the destination where it wants to send the segment. Okay, any segment is being sent by this client to this server. This client has to tell that on which socket it should be received by the server, because on that particular host a process on port number 53 will keep on listing the client request. So in the IP packet header it will have the IP address along with the port number. Source IP, source port number, destination IP, destination port number. What you have on the transport layer in the segment header? When we did the encapsulation on the TCP IP 5 layer model, a message comes from the application layer on the transport layer and it is divided into segments. Every segment will be having a attached header with it on the transport layer. This is the job of the transport layer, to attach a transport layer header with every segment, and that header will contain the segment number, the source port number and the destination port number. That segment will come from transport layer to the network layer. Network layer will attach another header, IP header. What the IP header will contain? Source IP address and the destination IP address. Very good. Now that IP packet contains inside its body the segment, and inside the segment it has its header with it, segment header, and in the segment header you have the source port and destination port, and in the IP packet header you have the source IP and the destination IP. What it gives you? The source socket and the destination socket. Khalas. And we need here the source socket and the destination. Is it clear to you now? Where is the source port number and destination port number, and where is the source IP and where is the destination IP? The segment is encapsulated inside the packet. So the packet does contain in it the source IP, destination IP, source port, destination port. So the socket is complete there. Clear? Sender explicitly attaches IP address and the port number of the destination to each segment, because segment is encapsulated inside the packet. Clear? OS attaches IP address and the port of the sending socket to each segment. Server can extract, when this segment is received on the server can extract the IP address and port of the sender from the received segment, that from which source port this segment came. Okay, why? Because when the server is going to send a reply, it will send on the same port number, because that will become the destination port number in the reverse context. Clear? The application, from the application viewpoint, UDP provides unreliable transfer of group of bytes, okay, stream of bytes, and UDP bytes are called the datagrams between the client and the server. The official terminology for the UDP packet is a datagram. Okay, in this class we instead use the UDP segment instead of using UDP datagrams. Okay. Now, what example we are going to take here for this communication socket programming in our example, we have the client side, we have the server side, okay, communication. The client is going to the client is a user who is going to type line of text, okay, on a prompt in the application program. What is the job of that application program? The client side application will accept line of text from the user who is typing a line of text. It will accept that line of text, the client side application. Okay. What the client program will do with that line of text? The client program will send that line of text to the server. On the server, another server process will be listening the requests which are coming from the client processes. The server will receive line of text. Who will receive on the server? The server process. It will receive a line of text on the server, and it will give it to another process whose job is to capitalize all the letters. These letters are typed by this client are the small letters. The server process will receive those small letters, and what it will do, it will convert those small letters into capital letters. Clear? And it will send back the modified line to the client. The server process will again send back the converted characters from small to capital back to the client machine from the server. Clear? The client, on the client computer, the client process will receive the line of text in the capital letters, and it will display it on the screen. This is our example. Okay. This is the interaction, client-server interaction on the socket using the ports on the client, UDP ports on the client and the server side. Server is running on host ID, on a particular host ID all the time, and server will create a socket, for example, on port X. Okay. Server socket is a datagram socket, means it is a UDP socket, connectionless socket. Okay. The client side, client socket, client's process will create a socket which will be the client socket, and it will also be a UDP socket. Okay. This socket will create a datagram, UDP packet or UDP datagram with the server IP address, which is the destination IP address, because this will be the source IP address, and the port number X of the server process port number. In this case, it will be a DNS port number. Okay, and it will send the datagram via the client socket. This client socket is created here, and after putting this information into the client socket, this datagram will be sent through the client socket to the server computer. Now, server computer is, on the server computer there is a process which is called the server process, which is listening for the client requests coming from the client sockets. The server side socket will read the datagram coming from the client socket. The server socket will read the datagram which are coming from the client socket, and it will write the reply in the server socket, and it will specify the client address with the client port number. So in the source, it will write its own server IP address with the server port number, source port and source IP. Source IP and the source port. Source IP is the IP of the server, and it is sending back the reply. Source IP, source port number. Destination IP, destination port number. Client IP and client port number, and give it to server socket, which will send it to the client socket again. On the client socket, we will read the datagram from the client socket into it. Okay, and it will close the connection. The client socket will close the connection after reading it and displaying it on the screen. This is the scenario how the communication will take place, and what we are going to develop an application. So this will be your project, okay, course project, that you have to execute this code, okay, by doing some modification in it. Okay. It is just reading the datagram and displaying it. Okay. Here there is no upper character conversion. Okay. Look here now. This is the example Java client using a UDP socket. From the keyboard you are inputting the characters. So input stream is going to the client process. What client process is going to do? It is going to output, send the packet. Recall that TCP segment sent the byte stream. TCP sent us byte stream to the server process. Now here the send packet process, this is the UDP packet which is going to the client UDP socket, and client UDP socket is going to put those UDP packet onto the network computer, okay, network internet. Okay. Now when the reply will come back from the server, the client UDP socket will receive the reply. It will send the reply and receive the reply. This is a door basically. This is a door into the client application from where the packets will go onto the network, and from where the packets will be received from the on which the packets will be received from the network. So this is basically a pipe is attached here to this socket, and the processor client process will be sending and receiving the packets, UDP datagrams onto the pipe, sort of a communication channel. Okay. So the UDP socket here will receive the packets coming from the server, and this will be the input received packet. Recall that the TCP received byte stream. Okay. So these packets will be received and it will be displayed on the monitor. Okay. Now this is basically the code. Okay. The Java client code for the UDP socket. Okay. These are the files which will be imported into the Java, okay, for input and for the network communication. And class is UDP client socket here, public and static void string. Okay, this is the code. Here this will create an input stream. Okay, it will be buffered and it will be going to read into the from the user input. Okay, it will be an input stream, the character which are being input by the keyboard, it will be received into this, and this code will create a client socket, okay, new datagram socket, new UDP socket, and then translate host name to IP address using the DNS. Whatever host name you have given here, that host name will be given to the DNS server in order to get it translated into an IP address, because the port number will be concatenated with the IP address, not the host name. We need a conversion from host name to IP address. Why? Because we will use here the IP address. We have to use here the IP address. So we do need a conversion for the DNS. Huh? Yeah, you can run it on a local LAN server. Okay, so that it will send data, okay, byte stream, okay, on that particular address, okay, and it will receive the byte stream on that particular address. Okay, string of the characters which are input at from the user will be a line read function will read that string input from the keyboard, from the client, from the user, and then the send process will send that stream to the network. Okay. Now create a datagram with data to send, length, IP address, port number. Now this data packet, send packet, will send the byte stream on this particular IP address, on this particular listing, on this particular port number. Okay. Now the client socket will send this packet to this particular IP and this particular port number. Okay. Datagram will be received on this particular packets on this particular port will be received, and these are being read by the datagram from the server. Whatever server will send, it will be received on this, and it will be read by the client side socket. Okay, it will receive the packet and read it, and that string modified sentence will be displayed here on the screen, and it will be received here, and it will be displayed here, which is received from the server, and plus the modified sentence will be displayed here on the client side. Okay, this is the complete client code, okay, which is going to create a input stream, going to create a client socket, going to translate the URL into IP address, and going to send a particular bit string on a byte stream on a particular IP address and port number, okay, and then going to read also back from the server to on the client, okay, and going to display it on the monitor. This is the server side code, okay. Same like that, it will use a UDP server class, and it will create a datagram socket on this particular port number. Look here, this is the port number on the server. When the client is going to send, it will use that port number as a destination port number, whereas on the server it is the source port number. Clear? It will also have two processes here to receive and send the data, okay. Create a space for the receive segment buffer here in order to receive the segment and put it into the buffer, okay. Get the IP address and the port number of the sender from where it is coming, the source IP and the source port number of the client. Why? Because when the server is going to send reply, it will become the destination IP and destination port number. You will reverse it, okay, and it will get the IP and port number of the sender. It will create a datagram to send to the client, and it will write out datagram to this socket end of the while loop back, and wait for another datagram to come, and then send it to the client. What is the UDP observation and questions here? Both client and server uses datagram sockets, which are the UDP sockets. Destination IP address and port number are explicitly attached to the segment where the segment should go, to be delivered, okay. What would happen if change both client socket and server socket to my socket? If it is changed, definitely the port number should be updated, okay. Can the client send a segment to the server without knowing the server IP address and or port number? No, definitely no. Okay. Can multiple client use the server? Yes, definitely. Multiple client, more than one HTTP request can come to this HTTP server. More than one DNS request can come to this server, DNS server. Why? Because might be the IPs, the port numbers of the different clients will be the same, because their operating systems does not aware of the one client operating system is not aware of the other client's operating system, that it is assigning which port number. So another client can have the same port number but different IP address on the same LAN, and that request will arrive here, because look here, this port, this destination IP port will be the same, the source port will be the same, but source IP will be different from this network when the request will go to this local DNS server. The local clients will have different IP address. So this is same, but only the different thing is client IP. So at least one thing should differ. If all the four things are same, the communication cannot be taken place, cannot happen. Clear? So this is the, can multiple client use the server? Yeah, they can use the server. Okay. Same like this, you have the socket programming with the TCP. Okay, here it has to create a connection first between TCP service is a reliable transfer of bytes from one process to another process. Now the socket programming using the TCP controlled by the application developer. The process part is controlled by the application developer, whereas the TCP with buffer variable is controlled by the operating system. And you have a socket in between on the host or on the server, okay. And a connection will be created first between the client and the server, okay, then the communication will take place. Whereas in UDP we don't need to set up a connection, because UDP is a connection less service, whereas TCP is a connection oriented service. There is a difference between the socket programming for the UDP and for the TCP. Clear? Now client must contact the server, okay, with the TCP scenario. Server process must first be running, Okay, definitely in either cases, in either case, either it is a UDP server service or it is a TCP service. In both the case, both the servers, they should be running. Why? Because they have to welcome the client request. They have to receive the client request. Okay. Server must have created socket door that welcomes the client contacts request. Client contacts the server by creating client local TCP socket. Okay, client local TCP socket specifying IP and address and port number of the server process. When the client creates a socket, client TCP establishes TCP socket will establish a connection to the server TCP socket. They must first handshake with each other. Okay. When contacted by the client, server TCP creates a new socket now in order to transmit the data for the server process to communicate with the client in order to receive the client request. And the client side will create another socket, client socket, in order to transmit the data to the server, and the server side will create a socket to receive the request sent from the client. Clear? Allow server to talk with the multiple clients, source port number used to distinguish clients. Okay, we will look into it more in chapter number 3. Application viewpoint. TCP provider provides a reliable communication in order delivery of the segments, transfer of the bytes through the pipe between the client and the server. Now this is the create socket on port X for the incoming request, welcome socket. This will be a welcome socket on the server side. Okay, and it will wait for the incoming connection request from the client. Okay, so it will be a connection socket, okay, which will use the welcome socket to accept the request coming from the client, create a socket, connect to the host, and particular host ID and port number, it will be the client socket. Okay, this socket will establish a connection with the server. So this is the TCP connection setup process between the client and the server. Then send requests using the client socket. Okay, here it will read request from the connection socket. Okay, and it will write a reply to the connection socket. Okay, the client socket will read the reply coming from the server, and it closes the connection, and here also it closes the connection. This closes the connection will close this connection, basically this socket. Switch off this socket and this connection will be teared down. Okay, should I stop or can I continue this? This is the same code, just this part was different because here basically the setup was taken place. Okay, this is the only difference between the UDP and the TCP sockets, because here a connection is established first, then the communication will take place, whereas what we have done already in the UDP, the connection setup process is not there. It was not there. It directly starts in the UDP. Whereas TCP first set up a connection, then it starts the communication. Yeah. No. Now a stream is a sequence of the characters that flow into or out of a process here through the keyboard. An input stream is attached to some input source, okay, for the process, example keyboard or socket. An output stream is attached to an output source, for example this is keyboard, this is the monitor, example monitor or a socket, and the client process will read the input from the input device and send the output to the output device. Okay, and it will give the input read from the client, input device will be given to the output stream to the server. So client's TCP socket will send it to the network, and whatever will be received from the network, it will be in from the server and it will be displayed to the monitor. Okay, this is on the application layer. So example client server application, okay, with the TCP socket programming. Okay, client read line from the standard input, okay, inform, okay, like this you have seen already here. This is the same code. Okay, read line from the socket, server converts the line to uppercase and send back to the client. The server process will do conversion, this conversion, and client will read the whatever will be received from the server, it will read it and it will print the modified line from the socket, okay, in from the server stream. Whatever has come from the server after the conversion, the client will receive it, read it and display it to the client process socket will read it and send it to the output device to be displayed on the monitor. This is the same code. Create input stream, create client socket to connect to the server, okay, for the connection, and create output stream attached to the socket to send it, okay, to the server. Create input stream attached to the socket, send a line to the server and read a line which is coming from the server. This is the client side code. This is the server side code. It is welcoming socket at port number 6789, which is listing the this is a socket, welcoming socket, and this is the in the loop it is basically waiting to on the welcoming socket, on the same socket which is welcoming socket is created already. On this same welcoming socket, the server will be waiting to receive the client requests. Once the client requests are being received on this, it will create a stream attached to this socket and it will convert it, and then the converted stream will be sent back, attached here, and it will be sent back to the client, okay, read in line from the socket, okay, from the client, and capitalize, convert it back, and it will be sent to the this is basically create output stream attached to the socket. Whatever it is reading, buffer in from the client, it is reading from the client basically in this buffer. This is a buffer created here to read the data. Whatever data is coming, okay, it will be kept here, and whatever data wants to send to the client, it will be kept here in this buffer output stream, okay. And this is whatever is client sentence mean, whatever is coming from the client, it will be kept here, it will be read here, and it will be converted into the capital letter, and then it will be right outline to the socket, okay, capital sentence, and it will be sent back to the client, okay. End of the loop, okay. To TCP observations are these, that the server has two type of sockets here. One is the server socket and the simple socket. When the client knocks the door on the door of the server, okay, on server socket mean the door of the server creates a connection socket to accept the connection request and completes the TCP connection, okay. The first socket is to set up a connection between the client and the server, okay. Then the destination IP and the port are not explicitly attached to the segment here in this case. Can a multiple in this port for the connection setup it is not required. Later for the communication we need it, exactly. Only the IP is required but not the port number, but later on we do need the IP and port number explicitly, okay. Can multiple client use the server? Yeah, definitely. In this case the answer is same, okay. So this is the summary of this chapter. You can have a look on this summary, and alhamdulillah we finished chapter number 2 today. In the next lecture we will start chapter number 3.